Thanks, Jordan. Today I'm going to go over the technical requirements for both EPA Draft Method 1633 and Table B-24 of the Quality Systems Manual version 5.4. This presentation is not going to discuss the policies or the timeline of implementation of policies for individual DoD services or the DOE. So who's my intended audience for today? Basically anyone that needs to understand the technical requirements for DoD ELAP accreditation for EPA Draft Method 1633. So that includes laboratories and the assessors that are going to be tasked with assessing them. It also includes project managers for projects that are planning on utilizing this method, both project managers in the laboratory that will be communicating with our contractors and project managers and government project managers, as well as government contractors and data validators as well. And last but not least, regulators involved with DoD and DOE facilities and projects that plan on utilizing our requirements. QSM 5.4 contains a couple of tables that are applicable to PFAS. First are the old tables that were in version 5.3, tables B-15, C-44, and C-45. We needed to retain these tables because we have ongoing projects that require the requirements of these tables to be met. They are not applicable to method 1633. The table that is applicable to 1633 is table B-24. It contains requirements that are in addition to those requirements contained in method 1633 itself. And again, tables C-44 and C-45 cannot be applied to table B-24. Also, what is not applicable to this table is any compliance testing that is being performed to determine the PFOA and PFOS content of AFFF concentrates for compliance purposes to the military specification MIL PRF 14385. The method that is applicable to compliance testing is DoD AFFF 01 Rev 1.0. This exception is made in the first row of the table B-24 itself. Table B-24, however, is applicable to the analysis of AFFF stocks and mixtures that is not being done for compliance purposes. I know I said I wasn't going to talk about policy, but I do need to talk about one existing policy. That's the DoD policy that requires a method compliant with table B-15 to be utilized for all media type other than drinking water. It's very, very likely that very soon this policy will be updated to require new projects and task orders after the 31st of December of this year to require the use of EPA Draft Method 1633 for all media type other than drinking water. We expect this policy to require a laboratory that is DoD ELAP accredited for Draft Method 1633 to be utilized. So that means you have to meet the requirements again of EPA 1633, the errata sheet, and all of the requirements contained in the QSM, meaning table B-24 and the general requirements of the QSM. So you can see, in addition to that, also we are expecting the policy to strongly encourage existing projects to transfer over to utilizing this new method as well. So you can see the clock is ticking, and we're going to desperately need laboratories to be accredited to this method very soon. So I don't think it can be said enough, and I can point you to the table at the very top of the table. Under the headers, you will see a statement that says all of the requirements contained in the EPA Draft Method 1633 must be met. This table contains additional requirements that must be met. Where the name of the QC samples listed in the table differ from the EPA Draft Method 1633 terminology, the corresponding EPA Draft Method 1633 terminology is provided in the comments column. So let's recap where you can find the requirements for DoD ELAP accreditation for EPA Draft Method 1633. The requirements for accreditation for this method are found in the method itself, EPA Draft Method 1633, and any errata sheets that the EPA publishes for this method, as well as the DoD DOE QSM 5.4 in its entirety, not just in the Table B-24. First, let's start with the scope of the method. The method is applicable for the analysis of 40 PFAS in aqueous, solid, and tissue samples. The analysis is performed by LCMS-MS. This analyte list is the method analyte list, not a DoD analyte list. There is no such thing as a standardized DoD analyte list, as I'm sure most of you are aware. When the method states when isomeric mixtures are present in a sample and a qualitative or a quantitative standard is commercially available, the sum of the linear and branched isomer concentrations is reported. If you look on this table, you'll see two superscripts, a superscript 1 and superscript 2. The superscript 1 designates the quantitative standards that are commercially available at this time. And superscript 2 designates where the qualitative standards are commercially available at this time as well. A lot of people have had some difficulties, I've heard, finding suppliers for the qualitative standards. I can tell you that I have found them to be available by many vendors, including Wellington, Sigma Aldrich, and Cambridge Isotopes. The method states that if such a standard is not commercially available, the suspected branched isomer concentrations are not to be included in the reported concentrations. So the designated 1 and 2 superscripts here will show you which analytes are going to be reported as the sum of isomers in your sample. Next, the method states that the laboratory must demonstrate the ability to generate acceptable results using the procedures in section 9.2. All sample preparation and extraction procedures must include steps that are included in sections 11 and appendices A and B. The method also states that modifications to the method may be made without additional EPA review to improve performance, provided that all performance criteria in the method is met. Changes in performance, sensitivity, selectivity, etc., that result from the modifications within the scope of 40 CFR Part 136.6 and Section 9.0 of this method must be documented. So any modifications have to be documented, as well as the results of these modifications has to be compared to the specifications of this method. Like other EPA methods, the laboratory is required to make an initial demonstration of capability that generates acceptable precision and recovery with this method. That section that covers that is section 9.2. The method also, like other methods, prohibits the use of alternative techniques and changes to the method that degrade the method performance without prior approval, and requires another initial demonstration of capability to be performed every time a modification is made to the method. If the changes that are made to the method affect the calibration, the instrument must be recalibrated per the method. And a modified method has to produce results that are equivalent to or superior to the results produced by the method as written. Once this equivalence or it's shown to be superior, the modified method can be routinely used thereafter. The method requires equipment to be cleaned prior to and after use, and also requires the PFAS content of disposable plasticware and filters to be verified on a batch or lot number basis. If this verification demonstrates that the PFAS levels are less than 1/2 the method limit or limit of quantitation, then this equipment can be used without cleaning. The method specifically states that glassware has to be cleaned by washing with detergent and baking in a kiln or furnace, and that prior to use, the baked glassware must be solvent rinsed and then air dried. There is one caveat for this requirement, and that's stated in section 6.2 that states that if blanks from bottles or other glassware show no detectable PFAS when using fewer cleaning steps, unnecessary cleaning steps and equipment may be eliminated from the process. The errata sheet the EPA has issued has made changes to section 4.2.2. The corrected text reads, all parts of the solid phase extraction manifold must be cleaned prior to samples with methanolic ammonium hydroxide 1% and air dried prior to use. Sonication with methanolic ammonium hydroxide 1% may be used for components that will fit into an ultrasonic bath. This is the big change. Previously, it required sonication. Now it's stating that sonication may be used. Smaller parts like the needles, adapters, reservoirs, and stopcocks associated with the manifold require rinsing with tap water prior to manual cleaning or this sonication and air drying. When in use after loading the samples but prior to the elution process, the chamber must be rinsed with methanolic ammonium hydroxide 1%. Section 4.2.3 states equipment used in the filleting, dissecting, shucking, compositing, and homogenization of tissues must be cleaned with detergent and hot water, then rinsed with ultra-pure water, followed by a series of solvent rinses. Section 4.3 states method blanks must be analyzed at the beginning and with each batch of samples. Section 4.3.1 states the reference matrix must simulate as closely as possible the sample matrices being tested. With respect to the material used for the tissue reference matrices, the source product must be verified to not contain detectable amounts of the method analyte. Note that's detectable amounts. That's not amounts greater than 1/2 the limit of detection. That is, anything detected should not be in those reference matrices. And lastly, with respect to interferences, the method requires the analysis of bile salt standards to be part of establishing the initial chromatographic conditions that are found in sections 10.2.2.5 and 10.3.5. This comes from the errata sheet. The reason for the errata sheet was initially it specified the TDCA standard, but as the errata sheet stated, if you use a different mobile phase other than acetonitrile, there are additional bile salt standards that need to be analyzed. That's why it's been changed. The section's been changed to state bile salt standards instead of TDCA standards. As far as safety is concerned, the laboratory prepared primary solutions must be prepared in a hood following universal safety measures, and the laboratory is required to be well ventilated and have controlled access and must develop a strict safety program for handling PFAS specifically. Gross losses to the laboratory ventilation system must not be allowed, and eye protection must be worn while working with exposed samples or pure analytical standards. Workers must be trained in proper method of removing contaminated gloves and clothing without contacting the exterior surfaces. Also, biosolid samples must be handled with gloves and opened in fume hoods and biological safety cabinets. Relative to equipment and supplies, there are some things that were specified in the method that I'd like to point out. First is relative to sample processing in the field. The tubing used in compositing equipment used in the field must be made of HDPE. Before use, the tubing must be thoroughly rinsed with methanol, followed by repeat rinsings with reagent water. Next, we have another correction from the errata sheet with respect to the tissue homogenizer. The method itself has some specifics relative to the type of tissue homogenizer. That information is incorrect and has been eliminated through the errata sheet. Next up, we have the solid phase sorbent in the SPE cartridge must have a pKa above 8. And also, the method states, if a cartridge with a different bed volumes used, the laboratory must demonstrate the new volume does not negatively affect absorption and elution through IDOCs. So again, you would have to have another initial demonstration of capability utilizing those different bed volumes. There are a couple of requirements with respect to reagents and standards that I thought would be important to point out. First is basically a requirement that by default. The method states the reagents prepared by the laboratory may be stored in either glass or HDPE containers. So those are the two containers that really your options are for storage. Proper cleaning procedures must be followed prior to use of those containers. So you need to ensure that those are clean, especially the glass containers if they are containers that can be reused. Section 7.1.2, there is a change based off of the errata sheet change that was relative to section 15.3.1. That 1.1% acetic acid was stated originally in the method as what is to be used for sample extract dilutions. That is not the case. The actual solution that's used to make sample dilutions is found in section 7.1.9. Section 7.1.17 states that the loose MV carb or equivalent must be used until the method is multi-lab validated. So cartridges are not permitted at this time. Once the multi-lab validation study is finished and we have the performance criteria based off of the loose MV carb, as long as a laboratory can meet the performance criteria that was accomplished with the loose MV carb using a cartridge, that point they would be permitted to use those cartridges. But until then, the loose MV carb or equivalent has to be used for this method. And section 7.2 lists the type of reference matrices that are typically used, that can be used for PFAS analysis. It basically states that reference matrices are matrices in which PFAS and interfering compounds are not detected, and that these reference matrices must be used in preparation of batch QC samples. Section 7.3 states that if the chemical purity is 98% or greater, the weight may be used without correction to calculate the concentration of the standard. Otherwise, it has to be used. The standards must be stored in the dark at less than 4 degrees C in screw-capped vials with foil-lined caps, unless the vendor recommends otherwise. The laboratory must mark the level of the solution on the vial and replace if loss occurs. All diluted solutions must be stored in glass or HDPE containers that have been thoroughly rinsed with methanol. Laboratories must also maintain records of the certificates of all standards. Copies of the certificates must be provided as part of the data package in order to check that proper calculations were performed. And again, in section 7.5, we had a correction that was documented in the errata sheet with respect to the biosalt interference check standard. Originally, it had to just contain TDCA, but a clarification has been made that if you utilize acetonitrile as your mobile phase in the instrument, then you continue to use a standard made of TDCA at 1 micrograms per milliliter. However, if you do not use acetonitrile and you have a different mobile phase, then that standard has to not only contain TDCA, but it has to contain TCDCA and TUDCA as well at 1 microgram per milliliter. Moving on to sample collection, preservation, storage, and holding times, the method requires samples to be collected in HDPE containers following conventional practices. Containers must have linerless HDPE or polypropylene caps. PTFE line caps are prohibited by the method. If sample collection techniques or sample volumes differ than that documented in the method, they must be documented. Section 8.2.1 requires the collection of a 500 milliliter sample for aqueous samples with the exception of leachates. It states to collect at least 2 aliquots of all aqueous samples to allow sufficient volume for the determination of percent solid and for pre-screening analysis. That second aliquot may be collected in a smaller sample container such as a 250 milliliter or 125 milliliter bottle. The method states that the entire aqueous sample that is collected must be prepared and analyzed, and that the subsampling should be avoided whenever possible. Therefore, if a sample volume smaller than 500 milliliters is to be used for analysis, that smaller volume should be collected in the appropriately sized HDPE container. Section 8.2.2 states to collect 2 100 milliliter samples for leachate samples in a similar manner as described in section 8.2.1 using appropriately sized containers. Sections 8.2.3 and 8.5.1 discuss the preservation, storage, and holding time requirements for aqueous samples. Section 8.2.3 has been revised per the errata sheet. Basically, the requirements for aqueous samples are that they must be maintained, protected from light at 0 to 6 degrees from the time of collection until they're shipped to the laboratory. The samples must be shipped as soon as practical with sufficient ice to maintain the sample temperatures below 6 degrees Celsius during transport and be received by the laboratory within 48 hours of collection. The laboratory must confirm that the sample temperature is 0 to 6 degrees Celsius upon receipt. Once received by the laboratory, the samples must be stored at either less than or equal to negative 20 degrees Celsius or at a 0 to 6 degree Celsius temperature range, protected from light in both cases until sample preparation. This is a change from the published method, which stated that all samples must be stored at less than or equal to negative 20 degrees C. So you have an option, either 0 to 6 degrees C or less than or equal to negative 20 degrees C. If the samples are stored at less than or equal to negative 20 degrees C, the samples may be held for up to 90 days until preparation. If they're stored at 0 to 6 degrees C, samples may be held up to 28 days until preparation, with the caveat that issues were observed with certain perfluorooctane sulfonamide ethanols and perfluorooctane sulfonamide acetic acids after 7 days. This is information that's included in the errata sheet. Section 8.3.1 discusses the collection of solid samples. It says to collect samples as grab samples using a wide mouth jars and fill no more than 3/4 full. Sections 8.3.2, 8.5.2, and 8.5.3 discuss the preservation, storage, and holding times with respect to solid samples. Again, section 8.3.2 has been modified per the EPA published errata sheet. Basically, these sections state to maintain solid samples protected from light in HDPE containers at 0 to 6 degrees from the time of collection until the time of receipt in the laboratory. And that the laboratory, once again, must confirm that the sample temperature is from between 0 to 6 degrees Celsius upon receipt. Once it's received in the laboratory, the samples must be stored in the dark at less than or equal to negative 20 degrees C or at a temperature between 0 and 6 degrees Celsius until sample preparation. This is where the change has been made in the errata sheet. Previously, it stated that samples must be stored at negative 20 degrees C or less. Samples may be held for up to 90 days from collection before analysis at either temperature ranges, with the caveat that samples may need to be extracted as soon as possible if NFDHA is an important analyte. Section 8.5.3 states that freezing biosolid samples is recommended due to off-gassing potential. Section 8.4 states that the field procedures must involve materials and equipment that have been shown to be PFAS-free. So this would mean that some pre-testing of some equipment may be necessary. It also states that if whole fish are collected, the fish should be wrapped in aluminum foil or food-grade polyethylene tubing, which actually should be polyethylene wrap, and maintain at 0 to 6 degrees C from the time of collection until sample receipt at the laboratory to a maximum of 24 hours. If longer transport time is necessary, samples should be frozen before shipping. Ideally, fish should be frozen upon collection and shipped to the laboratory on dry ice. Once received by the laboratory, these tissue samples must be stored in the dark at less than or equal to negative 20 degrees C until prepared. Unused samples should be stored in HDPE containers or wrapped in aluminum foil and stored at negative 20 degrees C. Samples may be held for up to 90 days from collection before analysis. Section 8.5.4 states to store sample extracts in the dark at less than 0 to 4 degrees C until analyzed. This really should be store sample extracts in the dark at 0 to 4 degrees C. If stored in the dark at this temperature, the method states that sample extracts may be stored for up to 90 days, but there is a caveat. There are some issues that have been identified with some of the analytes after 28 days. So if those analytes are analytes of concern for a project, or if NFDHA is an important analyte, a shorter hold time may be warranted. Moving on to some of the quality control requirements of the method, Section 9.1.2.2 states that records of modifications made to the method must be maintained, and that if alternate columns or column systems are used, all the requirements of the method still must be met. The laboratory also must spike all samples with isotopically labeled compounds to monitor the method performance, so the EISs and the NISs. Both. And Section 9.1.6 states that the laboratory must maintain records to define the quality of the data generated. All of these are basic requirements that are also found in the Quality Systems Manual. With respect to the initial demonstration of capability requirements of this method, they fall in line with all other the EPA methods, especially this other 1600 series methods. They require an initial precision and recovery demonstration that must be performed for each method media type and must include at least one method blank and 4 aliquots of matrix type spiked with method analytes. They must be prepared and analyzed in exactly the same manner as the field samples, including all of the cleanup steps. And you must determine the average % recovery and relative standard deviations for each method analyte and EIS. The average % recoveries in RSDs must be within the method limits. That's what the method states. Currently, there are no method limits stated in the method. They are yet to be determined. They will be determined off of the multi-lab validation study. So that's highlighted in blue because that's where some of the requirements of the table B-24 would apply. Section 9.2.2 has the requirements for the method detection limit determination. The method states, as all the other EPA methods state, that it must be established using the MDL procedure at 40 CFR 136 Appendix B. The method goes on to state that all samples must be spiked with EIS compounds and all sample extracts with NIS compounds. Samples must be analyzed according to section 11 through 16. And you must calculate the percent recovery of the EIS using the NIS method and the equation in section 14.5.2. The recovery of each EIS and NIS must be within the table 9 and 10 limits once the tables are finalized. They aren't finalized right now, so there are no hard limits for EIS and NIS recoveries in the method at this point. However, the method does state that if recoveries are outside limits, additional cleanup steps must be employed to bring the recoveries within limits. If it still fails, aqueous samples must be diluted, and for solid samples, a smaller sample amount must be prepared using per section 15.3. So these EIS recoveries and NIS recoveries that you've calculated must be assessed and recorded per the method, and they must be assessed to intervals of the average of at least 30 recoveries plus or minus 2 times the standard deviation per the method. The EIS and NIS assessments must be updated on a regular basis. So update those charts on a routine basis. That's also a standard requirement of the Quality System Manual. A method blank must be analyzed with each sample batch and must be similar matrix to the samples in the batch. That was previously stated also in section 7.2. The method blank must be analyzed before the associated OPR in the batch or LCS of the batch. There are some mass calibration and mass calibration verification requirements contained in the method. Mass calibration is required at least annually and must be repeated on an as-need basis. It must be performed using calibration compounds and procedures prescribed by the manufacturer. The procedure used for mass calibration and mass calibration verification must evaluate an ion range that encompasses the ion range of analytes of interest of this method. That was a requirement of Table B-15 as well, by the way. The MRM analysis is required. Section 10.1.1 states other ions other than those listed in Table 2 may be used. However, ions that do not sufficiently discriminate between method analytes and co-eluting interferences must be avoided. The method also states that MS parameters must be methodically changed until optimal analyte response are determined. Obviously, there's a little give and take on the responses and having the optimal response for every analyte. So while the method states that other ion transitions can be used, we've made a further clarification on that. What we've basically said in Table B-24 is that if a qualitative or quantitative standard containing an isomeric mixture of branched and linear isomers for an analyte is commercially available for an analyte, the quantification ion must be the quantification ion identified in Table 2 of the method, unless interferences render that product ion unusable as the quantification ion. So the reason for this, what we're saying is all of those analytes that you have branched and linear isomers for, be it quantitative or qualitative, there's only a handful of them, but we require you to use the ion transition, the quantification ion transition identified in Table 2 of the method. The reason for this is the transition that was selected for the quant ion for these analytes is the transition that has the greatest responses for those branched isomers as well as the linear isomer. So we wanted to make sure that if those branched isomers are present in a sample, that they would be sufficiently quantitated. We do have the caveat, however, if you have interferences present in a sample, you can have a technical justification. That is a technical justification for that particular sample to utilize a different quant ion. If it is unusable, and that is the case, you have selected another ion for quantitation, then you need to get project approval for use of that alternative ion as your quant ion before you utilize it. Table B-24 does not require you to flag the data. However, we do require you to provide a technical justification for those cases where you had an interference in a sample and you were forced to use a different quantification ion. And the comments section just provided you a list of the analytes that we have qualitative and quantitative analytical standards for that can contain an isomeric mixture. With respect to calibration and standardization, mass calibration verification is required to be performed following every mass calibration, and the instrument software instructions must be followed to confirm the mass calibration, mass resolution, and peak relative response. So all of the requirements that the manufacturer has with respect to those elements must be met. Verification must be performed using standards whose mass range brackets the masses of interest. That includes both the quantitative and the qualitative ions. Instrument mass resolution must be at least unit resolution. Unit resolution is accomplished when the value of the peak width at half height is within 0.5 plus or minus 0.1 AMU or Dalton. Laboratory must measure the amount of peak drift from the expected masses. If the peak apex has shifted more than approximately 0.1 Dalton, then you must recalibrate the instrument. Section 10.2.1 states that basically the chromatographic conditions that have to be consistent across the board for analysis of all standards, blanks, IPRs, OPRs, and samples. Modifications of the solvent composition of the standard or extract by increasing aqueous content to prevent poor peak shape is not permitted. And the time the LC sits at initial conditions must be kept constant and as short as possible. The method also states that you must inject compound solutions to determine the retention time of each individual analyte. This next requirement should look really familiar to those laboratories that met the requirements in Table B-15. The retention time of the method analytes, the EIS, and NAIS compounds must be set using the midpoint of the iCal on days the iCal is performed. On days the iCal is not performed, the retention time of the initial calibration verification of that day is used to establish the retention time windows. Method analytes and EIS and NIS compound retention times must fall within 0.4 minutes of the predicted retention times established by the midpoint of the iCal or that daily initial CV, whichever was used. The retention time of all branched isomers whose retention times were established by qualitative or quantitative standards must fall within the retention time window for that analyte. So that retention time window has to be big enough to encompass all of the retention time of all of those branched isomers. For those method analytes with exact corresponding isotopically labeled analogs, so that's 24 of our 40 method analytes, the method analytes must elute within 0.1 minutes of their associated EIS compounds. The recent publication of the errata sheet updated the requirements contained in section 10.2.2.5. This section requires the analysis of a bile salt interference check standard. This standard is required to contain TDCA if your mobile phase is acetonitrile. If it is not acetonitrile, then it must contain TDCA as well as TCDCA and TUDCA. The analysis of this standard must show that these compounds do not collude with any of the target analytes, EIS, or NIS compounds. Separation must be demonstrated that shows at least a 1 minute separation between these bile salts and the retention time window of PFAS. Section 7.3.3 once again states that quantitative standards must contain a mixture of branched and linear isomers for method analytes if they are commercially available. We have the list in the method of which ones are commercially available. And section 7.3.5 states that all analytes with commercially available stable isotopic analogs must be quantified using isotope dilution. So that's the 24 of the 40 analytes. Sections 10.3 and 7.3.4 state that prior to analysis and after mass calibration check has been met, initial calibration must be performed using a series of at least 6 solutions, with at least 5 of the 6 calibration standards being within the quantification range. If a second order calibration model is used, then you have to add 1 more additional concentrate as the required number of standards. So instead of 5, you're going to have at least 6 within the quantification range. The initial calibration solution contain the entire suite of isotopically labeled compounds, NIS, and target compounds. And these standards must not undergo solid phase extraction. So what we're saying here is you have to analyze six solutions, but at least 5 of those have to be within the quantification range. So that means from the limit of quantitation to your highest calibration point. And then second order, 6. Section 10.3.1 states that the instrument must be calibrated whenever the laboratory takes corrective actions that might change or affect the initial calibration criteria, or if either the CV or the instrument sensitivity check, the ISC acceptance criteria, has not been met. Sections 10.3.3.1 and 7.3.4 state that the lowest calibration standard must meet a signal-noise ratio of greater than or equal to 3:1 and be at a concentration of less than or equal to the limit of quantitation. So that means that all calibration standards that are used, they're actually used in the calibration curve, not just analyzed, but utilized in the calibration curve, they all must meet the 3:1 signal-noise ratio, not just the calibration levels that are within the quantification range. Also noted in the method is that the same sample injection volume must be used for all standards, samples, blanks, and QC samples. The method gives you 2 options for evaluation of the linearity of the instrument calibration. Either are the relative standard deviation or the relative standard error. Both must be less than or equal to 20% to establish the instrument linearity. Section 10.3.4 states that if the signal-to-noise ratio criteria or the instrument linearity criteria for the initial calibration are not met, then corrective action must be taken to achieve this criteria. All calibration criteria must be met before any samples or required blanks are analyzed. In addition to these requirements, in Table B-15, we have a requirement for an initial calibration verification. So this is performed after each iCal, and is the standard, it's made from a standard that's made from a second source material. All analyte concentrations must be within plus or minus 30% of their true values. This should look very familiar to the folks that have done Table B-15 analyses, as this is identical to our previous requirement. The corrective actions associated with a failing iCal verification is that you have to correct the problem if you can and rerun the ICV. If the problem persists, then you're going to have to probably repeat the iCal. Flagging is definitely not appropriate for a failing ICV because no samples are to be allowed to be analyzed until an acceptable ICV is analyzed. Sections 7.3.4 and 14.2 require the analysis of an Instrument Sensitivity Check Standard, or ISC standard. This standard must be at the concentration of the lowest calibration standard within the quantification range and is required to be analyzed at the beginning of the analytical run. The signal-to-noise ratio of the ISC standard must be greater than or equal to 3:1 in order for the analysis to proceed. The method also provides an interim acceptance limits for native analyte and EIS compound recoveries. It states that 71-30% recovery for 90% of the native and EIS compounds should be used, with other recoveries achieving 50-150. The calibration is verified with a calibration verification standard at least once every 10 field samples or less, and after all sample analysis through the analysis of a mid-level calibration standard. So note we have, again, something highlighted in light blue here, and that indicates that we have a clarification in our table B-24. And basically that clarification is that all analyte concentrations must be within plus or minus 30% of their true values. We do not allow for 10% to fail this criteria. We are saying that we're going to be a little bit more stringent, and all of the analytes must, and EISs must meet this 30% criteria. We've also stated that if it fails, you can rerun it after you correct the problem. If it persists, again, you're just going to require the possibly that you have to repeat your initial calibration. We also state that there is no flagging that is appropriate, that basically no sample shall be analyzed until the acceptance criteria has been met. So no samples can be reported with a failing ISC standard. And once again, section 10.3.5 had a clarification in the errata sheet relative to the bile salt interference check standard. This standard is required to be analyzed after the initial calibration prior to the analysis of tissue samples to check for interferences caused by bile salts. If the interference is present, the chromatograph conditions must be modified to eliminate the interference from the bile salt, from the bile salts, such that they fall outside the retention time window of PFAS by at least 1 minute. And the initial calibration would have to be repeated. It states that if tissue sample analyses are not being conducted, this check may be skipped. You can see it's in blue. We've made a clarification to this statement in table B-24. And our clarification in B-24 is that this bile salt standard, whether it is required to contain that TDCA or the TDCA and the other two bile salts that are noted in the method, has to be analyzed on a daily basis prior to the analysis of any samples, regardless of their matrix type. Partly this is because there's been some published research that has demonstrated that these bile salts can be present in biosolids and potentially surface waters. And we want, until we have data that says otherwise, we're going to err on the side of caution and require the analysis of this one standard on a daily basis. Again, as I stated earlier, the method does not require all samples to be pre-screened. However, it's highly recommended by the method. Essentially, you do not have justification for analyzing a sample and using an aliquot of the sample and not the entire sample that was collected without pre-screening a sample. This protects both the laboratory and the project in that if you analyze a sample, if you process a sample in its entirety using the whole sample and it contains very high concentrations of PFAS, it has the potential to contaminate not only the entire system that the laboratory is using for preparation and for analysis, but it also can contaminate the other samples that are included in that batch and other batches that follow in the preparation process. The method states that if high level of PFAS are present in the sample as determined by the screening of the sample, a lower volume is required for sample analysis. It goes on to state that if the laboratory is going to use a subsample of an aqueous sample, the laboratory must notify the client before processing the subsample. And data reported from a subsample and not the entire sample that was collected has to be stated as such in the report. Section 11 states not to use any fluoropolymer articles or task wipes in the extraction procedures, and to use only HDPE or polypropylene wash bottles and centrifuge tubes. The procedure also requires the preparation of the entire sample again in section 11.2, and states that because the sample volume used for leachate samples differs from all the other aqueous samples, they cannot be included in the same sample preparation batch as the 500 milliliter samples. So because the method does not include the analysis of product or AFFF concentrates, Table B15 needed to include some requirements specific to AFFF samples or concentrates. So the reason for this is because during the validation of DoD AFFF 01, we noted that there needs to be a significantly long dissolution time for AFFF aliquots in reagent water for the preparation of the AFFF sample. So we have required for each AFFF sample that's analyzed in accordance with 1633 for those samples to be subsampled in duplicate in accordance with the DoD AFFF 01 section 11.2.9. So it also should be noted that in lieu of the LCSD required in that section, in section 11.2.6 of the DoD AFFF method, one MS-MSD pair must be prepared for each batch of AFFF samples. So what we're saying is for AFFF samples, you have a method blank, you have a laboratory control sample, an LCS, an MS, an MSD, sample, and sample duplicate. And for every sample, you have a duplicate. All of the AFFF samples must be processed in duplicate in the same manner as whole aqueous samples. So once you follow that process that's in the AFFF 01 method to prepare that aliquot has to be processed in the exact same manner as whole aqueous samples utilizing the draft method 1633. This is the same as for any other sample that requires a smaller aliquot of a sample to be prepared in accordance with the appendix of the method. Again, those dilutions of those samples are taken through the exact same process as whole aqueous samples from that point forward. Section 11.2.3 lists the quality control samples that are required to be extracted with each batch of aqueous samples. They include a method blank and 2 ongoing precision and recovery check samples. These samples are created using PFAS-free water in HDPE bottles and should be the volume of water that is typical of the samples in that batch, so typically 500 milliliters for this method. One of the OPR samples is spiked with native standard solution at roughly 2 times the limit of quantitation. That's going to be your low-level OPR. This will verify your limit of quantitation. The other OPR is spiked at a concentration at the mid-level of the calibration. If this criteria is not met, then you should contact the client to find out any additional measures that they're going to require you to take. Those analytes in the sample that fail to meet this criteria should be flagged in the parent sample with a J flag indicating that there is an estimate and the criteria is not met, and this failure needs to be explained in the case narrative. Obviously, the 30% criteria is only applicable to those analytes that are detected and quantified in the sample at concentrations greater than or equal to the limit of quantitation. Section 11.3.1 states that for soil and sediment samples, 5-gram dry weight soil aliquots are utilized, and for biosolids, 0.5 grams dry weight is utilized. Because of this difference in sample amount that's used in the preparation process, biosolids have got to be prepared in different batches, their own batches basically, than other solid samples. They cannot be included in soil and sediment batches, because this is all because you're required by the method to utilize the same volume of material, reference solid material, as you utilize for your samples, for your QC samples that are included in your batch. Section 11.3.2, again, just like the aqueous sample batches, requires a method blank and 2 OPR QC samples to be included in each preparation batch. One of those OPRs, again, at a low-level OPR spiked at 2 times the limit of quantitation, and the other OPR spiked at the mid-level calibration point. This section also states that you should wet your reference solid material with reagent water. This is because we have found that if it is excessively dry, you will lose your EIS compounds prematurely. This precaution is also taken, it should be noted, with your actual soil and solid samples, that if they are found to be excessively dry, reagent water is added to those samples as well. So QC is not being treated differently than the soil samples themselves. So section 11.4 basically says that the laboratory has to find out exactly how they're to process their tissue samples. This is going to be dependent on the project itself. That's all going to come from your QAPP and your requirements for your project. The section also states that the samples must be prepared and homogenized. Section 11.4 also provides the laboratory with some criteria if they have to dissect the whole fish to obtain the appropriate tissue for analysis, and also requires that homogenized samples be stored in clean HDPE containers and stored frozen until they're used. Section also states that if a grinder is used after the entire sample's been processed, and the ground tissue is mixed with a spoon, you have to transfer it back to the grinder and repeat the grinding process at least 2 more times until the homogenized tissue has a consistent texture and color. This is really critical for tissue samples. The method requires 2 grams of the homogenized tissue to be used in the sample preparation procedure, and requires the same type of QC samples to be utilized. So you have a method blank and 2 OPRs again using a reference tissue matrix, and again, one spiked at 2 times the LOQ and one spiked at the concentration of the midpoint calibration point. each of the sample preparation sections, those for aqueous, solid, and tissue, all state that if a matrix spike is required, then the matrix spikes should be spiked at the midpoint of the calibration. If you do not know the concentrations of the samples, if not, they should be spiked at 3 to 5 times the background concentrations determined by screening the unspiked sample. Note that's in blue, meaning we have another clarification in Table B-24 relative to this statement. And that is in addition to your method blank, your low-level OPR, and your OPR, or for in QSM terms, your LCS and your low-level LCS. You are also required to prepare and analyze a matrix spike and matrix spike duplicate with each preparatory batch. A lot of people are like, why is this needed? You use isotope dilution. You're not using isotope dilution quantitation for all of your analytes. You're only using it for 24 of those analytes. We do not have analogs for all of the method analytes. So we decided we're going to require a MS-MSD pair for each preparation batch. Section 11.3.9 is talking about the concentration of each of the sample extracts and the volume at which you need to concentrate them down to. It states that if the extract volumes appear to be stop dropping, the concentration must be stopped, and the volume at which it was stopped at has to be recorded. And Section 11.3.9 kind of states the obvious in that the extracts must be concentrated to remove the methanol, as the excess methanol during SPE cleanup results in very poor recoveries of the C13 and C14 carboxylic acids and the C10 and C12 sulfonates. That's been demonstrated multiple times in research projects and in the single lab validation study method development. Section 12 states that all matrices must undergo solid phase extraction and carbon cleanup to remove interferences. That is not negotiable. That is a key component of this method. Every single sample has to undergo solid phase extraction and carbon cleanup. And again, it's noted in Section 12, the note says that carbon cleanup is required. That again is just reiterated. In Section 13 of the method, we move on to the instrumental analysis, the routine analysis of samples. That basically says in Section 13.3 that after the successful initial calibration has been completed, then the analytical sequence for batch samples is as follows, and it lists them out and says that the injection volume of samples and QCs must be identical to the volume used for calibration standards. Standards and sample extracts must be brought to room temperature and vortexed prior to aliquoting into an instrument vial in order to ensure homogeneity of the extract. I can tell you that there are some samples, especially some matrices, that will separate out and you're going to get very poor recoveries and really odd looking results if you do not bring those samples up to room temperature and vortex those samples prior to aliquoting. So your sample sequence goes instrument blank, instrument sensitivity check, instrument calibration verification standard, so that's CV or CCV, your qualitative identification standards, instrument blank, method blank, low-level OPR, and OPR, biosalt standard. It did originally say TDCA standard, but as you know, the errata sheet has changed that to biosalt standard. In parentheses, it has if only tissue samples are being analyzed. We know that that's different for the DoD QSM requirements, so that's in blue. You analyze 10 field samples and a calibration verification standard. After each calibration verification standard, you're required to run an instrument blank, and then you continue on throughout your analysis. So again, we've been through this before. The biosalt standards are required daily regardless of the matrix type of the samples being analyzed that day. That is the one difference. Again, it's not in place of the requirement, it's in addition to. We require it on a daily basis, regardless of the sample type. And next, we move on to the performance tests during the routine operations that are required to be successfully completed with each routine analytical sequence. They include the mass calibration must be performed prior to the analysis of the initial calibration curve, and the mass calibration must be verified prior to the analysis of any QC samples. If the requirements of Section 10.1 cannot be met, the problem must be corrected before analysis can proceed. If any samples in the previous shift may have been affected by poor mass resolution, they must be reanalyzed. The method requires instrument blanks to be analyzed at a frequency of at the beginning of the analytical sequence and after the analysis of high concentration samples. These include samples themselves, the highest calibration standard, and calibration verifications. As you saw in the sequence, you run an instrument blank after every CV. Since the method doesn't really have any clearly stated requirements for the instrument blank as far as acceptance criteria, we included in Table B-24 the evaluation of the instrument blank with respect to the limit of quantitation, that being that the concentration of each analyte must be less than or equal to 1/2 the limit of quantitation. This falls in line with our method blank criteria. We go on to clarify that if the criteria is not met after the highest calibration standard, the calibration must be performed using a lower concentration for the highest standard until the acceptance criteria is met, because that will demonstrate at the point at which you would not expect carryover in samples. If sample concentrations exceed the highest calibration standard and the samples following exceed the acceptance criteria, i.e. greater than 1/2 the limit of quantitation, they must be reanalyzed as well using a fresh aliquot of sample extract. Again, you possibly contaminated that vial, you need to go ahead and re-aliquot, get a fresh aliquot of those sample extracts and rerun those. Flagging is only appropriate in cases where the extract cannot be analyzed or re-extracted. And like a quick comment in the comment section, when we talk about CVs in the method, it's equivalent to CCVs in the Table B-24 requirements. So, calibration verification, CVs or CCVs, whatever you want to call them, must be analyzed after passing the MS resolution and successful ICAL is achieved prior to the analysis of samples, and it is the analysis of a mid-level calibration standard, so that CCV or CV has to be at a concentration of the mid-level calibration standard. The calibration verification standard has to be analyzed at the beginning of each analytical sequence after every 10 samples or less, and at the end of the analytical sequence. This is standard. This is the old requirements of B-15, nothing new here. You calculate the concentration of each native and isotopically labeled compound in the CV using the equations in the method. And the recovery of the native and isotopically labeled compounds in the CCVs or CVs must be within 70 to 130% criteria. If the criteria is not met, you have to recalibrate the instrument according to Section 10.3. So for the analytes that a standard is commercially available that contains branched and linear isomer mixtures of an analyte, a qualitative identification standard is required to be analyzed once daily at the beginning of the analytical sequence to confirm the retention times of the linear and known branched isomers or isomeric groups of an analyte. Again, thinking back to our analytical sequence, the method blank is analyzed after the solvent blank prior to the analysis of samples. If that method blank is found to contain analytes greater than the method limit or LOQ, or at greater than 1/3 the regulatory compliance limit, or greater than 1/10 the concentration of samples in the batch, whichever is greatest, the analysis must be halted and the problem must be corrected. If the failure cannot be resolved, the laboratory must document and report failures unless they are not required to be reported as determined by the regulatory or control authority. Results associated with failures of analytes regulated in a discharge cannot be used to demonstrate regulatory compliance, and failures do not relieve the discharger of reporting timely results. So you have a bunch of things here, highlighted here in blue. We obviously have some additional requirements relative to the QSM for those elements. So we evaluate our method blanks to a little bit more stringent requirements than method 1633 does. They're looking at it relative to greater than the limit of quantitation or method limit. We require no analytes to be detected at greater than 1/2 the limit of quantitation or 1/10 the amount measured in any associated sample, or 1/10 the regulatory limit, whichever is greatest. So it's a little bit more stringent than the analytical method itself. We went on to provide some additional clarification with respect to corrective actions. We said you have to correct the problem. If required, you have to re-extract and reanalyze the method blank in all of the QC samples and field samples that were processed with the contaminant blank. Samples may be re-extracted and analyzed outside of holding times as necessary for corrective actions associated with QC failures. You have to examine the project's specific requirements and contact the client as to the additional measures to be taken. As far as flagging criteria is concerned, if reanalysis cannot be performed, data must be qualified and explained in the case narrative, and a B flag must be applied to results of for that specific analyte in all samples in the associated preparatory batch. So after you analyze the method blank, you have to analyze the OPRs prior to analyzing your samples in the batch to ensure that the analytical process is under control. Section 14.5.4 provides some guidance as to the requirements relative to creating your updated QC charts relative to the recoveries of the OPR QC samples. Section 14.5.3 states that for native compounds and isotopically labeled compounds, you need to compare the recoveries to the OPR limits given in Table 5, and if they aren't met, you have corrective actions that need to be taken. Again, those limits that are stated in Table 5 are not appropriate currently. They will be appropriate once we have new data in there that has been generated from a multi-lab validation study. So again, you see this is highlighted in blue, stating that we have an additional requirement in the Table B-24. So to provide our projects with some baseline criteria for the OPRs, LLOPRs, LCSs, LLLCSs, whatever you want to call them, they're all the same thing. We provided in Table B-24 some general criteria that needs to be followed. So basically what we say is that when you're generating your in-house acceptance criteria, the preliminary limits that you use while you're generating, before you generate those limits, is 40 to 150% recovery until you generate those limits. After you generate, those limits are generated, the criteria we have is for that lower limit. That lower limit cannot fall below 40% recovery. Where did we get 40 to 150 and this lower limit of 40%? We got it from looking at the single lab validation study and allowing for greater variability based on the fact that we know when we look at it relative to 10 laboratories or 20 and 50 laboratories versus one laboratory, there's going to be greater variability. We went on to provide some additional clarification for corrective actions. We stated that samples may be re-extracted and analyzed outside of holding times as necessary for corrective actions associated with QC failures, and that the project-specific requirements must be examined, and you need to contact the client when you have LCS failures or LLLCS failures for additional steps that must be taken. Again, flagging criteria, data must be qualified with a Q qualifier when the criteria is not met and explained in the case narrative. And again, in the comments section, we equate the LCS to the OPR and the LLLCS to the LLOPR. Also wanted to mention that when we were talking about IPRs, the evaluation of the IPRs should be against the requirements of the LCS that are stated in Table B-24 when you're generating your IPR. You would want to see that 40 to 150% criteria being met, because that's the criteria of the method for your ongoing precision and recovery standards. So obviously you would have to, in order to demonstrate that you can achieve the method, your IPRs would have to be able to achieve those limits as well. And since the method does not require a matrix spike duplicate to be analyzed, we had to put in some criteria for MSDs as well in Table B-24. So the requirements are in-house LCS limits if the project limits are not provided. Otherwise, you use the project limits. The RPD between the MS and MSD has to be less than or equal to 30%. None of this should look new to anybody. Same requirements as were stated in the Table B-15 requirements. Corrective actions, with respect to that, contact the client, look at the project requirements, contact the client for additional measures to be taken. Again, analytes that fail in the parent sample, you're going to apply a J flag to and discuss that in the case narrative. And lastly, the method had a few requirements relative to data analysis and calculations. Section 15.1.1 states the signal-to-noise ratio of peaks must be greater than or equal to 3:1 in order for a concentration to be reported. If this criteria is not met, the analyte must be reported as non-detect. A few sections in the method provide retention time requirements for target analytes and EIS and NIS compounds. They state the retention times must fall within plus or minus 0.4 minutes of the retention times of the midpoint of the ICAL standard or initial daily CV, whichever was used for the analytical batch. In addition, for method analytes with exact corresponding isotopically labeled analogs, so that means the 24 out of the 40 PFAS analytes, the method analytes must elute within 0.1 minutes of their associated EIS. The retention time window width must be wide enough to encompass all isomers of that analyte for those analytes whose quantitation include their branched isomers as well as their linear isomer. Section 15.1.3 states the laboratory must follow the identification requirements specified by the client. It also states that if none are provided by a project, that there are some general requirements that have to be met. They are, for concentrations greater than the LOQ or equal to the LOQ, the total quantification ion response to the total confirmation ion response ratio must fall within plus or minus 50% of the ratio observed in the midpoint ICAL. It also states that if projects require reporting limits below the LOQ, which the DoD does, the response ratio must also fall within plus or minus 50% of the ratio observed in the initial daily calibration verification. Section 15.1.4 states that if this criteria cannot be met and all the sample preparation avenues have been exhausted, that the data must be reported with a qualifier identifying the concentrations as an estimate. If the criteria are not met for the standards, the laboratory must stop analysis of samples and correct the issue. So we've had a couple of items in blue on the last two slides. So those were some things that we further we had further requirements for in Table B-24. So Table B-24 under the ion ratio column, we had a minimum frequency of all analytes detected in the sample. So that means down to the detection, not down to the limit of quantitation. So as the method stated, there are additional requirements for those analytes that are detected below the limit of quantitation that must be met. We also specified further the flagging criteria that would be required. The method itself required data to be flagged, but it did not provide any information on what flag data qualifier needed to be used. In accordance with the typical DoD QSM requirements, we are requiring any failure to be discussed in the case narrative as well as being flagged. So we had made that clarification as well. The data qualifier that we're going to use for ion ratio failures is an I qualifier. It used to be a Q qualifier, but you know Q is associated with other elements, the quality control elements that failed. We wanted to make this one its own unique flag, and that's why we're using this new I qualifier for ion ratio failures. So again, these requirements are in addition to, and they just further specify requirements to the requirements of the method itself, not in place of, but in addition to. Concentration of method analytes must be determined with respect to EIS concentrations, and EIS concentrations must be determined with respect to NIS concentrations. Section 15.2 also states that other equations may be used so long as they produce the same concentrations as the equations presented in this section. Once again, this section also states that the results must be reported for method analytes in their acid or neutral form. The recently published errata sheet updated sample dilution requirements that are found in section 15.3.1. This section now states that if the Q1 areas exceed the calibration range, the sample must be diluted with methanolic ammonium hydroxide and acetic acid solution that is found in section 7.1.9, and the dilution factor cannot exceed 10x. If the EIS dilution responses meet the requirements for retention time and signal to noise that are found in sections 15.1.1 and 15.1.2, and the EIS dilution recoveries are greater than 5%, then the compounds associated with those EISs may be quantified and reported using isotope dilution. The laboratory is to use EIS recoveries from the original analysis to select the dilution factors needed. If EIS responses in the dilution do not meet the requirements in sections 15.1.1 and 15.1.2, or a dilution greater than 10x is needed, then the measurement is not reliable, and therefore a smaller aliquot of sample must be prepared and analyzed. All compound concentrations, detection limits, and minimum levels must be adjusted to account for any dilutions made. With respect to NIS compound recoveries, the method really does not have any criteria for recovery at this point in time. So Table B-24, we wanted to set up some guidelines for minimum recovery. We set that at 30%. So the NIS areas must be greater than 30%. So with respect to samples that have still theoretically should have the full amount that was spiked in. So those are undiluted samples, sample extracts, and sample extracts that were maybe diluted and had to have additional NIS added to that dilution, because the original NIS analytes were diluted out because you had to rerun it at such a high dilution. Those are required. Their areas need to be greater than 30% of the average area of the calibration standards. With respect to samples that have a dilution factor, so you made a dilution, say maybe a 10x dilution, you still had an NIS in your sample at a concentration great enough that you could still see the NIS peak, and you did not have to add any additional NIS standard to your dilution. With respect to that, you have to basically take the dilution factor into account when you're looking at those area counts, and then base it off of that and looking at 30% of the average area of the calibration standard. And with respect to corrective actions, we made an additional clarification that you need to repeat the analysis using a fresh aliquot of the extract again. If the failure does not confirm and the second analysis passes, great, report the second analysis. If the failure confirms, you need to examine your project-specific requirements and contact the client for additional measures to be taken. Also, with respect to flagging criteria, we state that you have to document it, note it in the case, and discuss it in the case narrative, and apply a Q flag to the results associated with the failure. I should say that the requirements of Table B-24 relative to EIS and NIS recoveries also apply to your initial demonstration of capabilities relative to NIS and EIS recoveries, because clearly, if those are the requirements that you're going to be held to, your initial demonstration of capability has to demonstrate that you're able to meet those requirements. In the case of samples that require dilutions, the method requires that only the analytes that caused the need for a dilution be reported from the dilute analysis. All other compounds must be reported from the least dilute level. Recoveries of all EIS compounds must be reported in all field samples and QC samples. If sample extracts were diluted and analyzed, the laboratory is to report the EIS recoveries from both the original analysis and the analysis of the dilution. Results reported with systems not in control, i.e. some QC failures, must be documented and reported as a qualifier on results unless the failure is not required to be reported as determined by the regulator or controlling authority. And with that, I thank everyone for their attention and patience in getting through all of this information. I know that it was a lot to throw at you in one time period. If you have any questions, again, like Jordan said, don't email me, email Matthew Lloyd your questions, and we will address them accordingly. Thank you.